Hello, class. This is a continuation of the recorded lectures for Chapter 4. And after reviewing one more time, I decided to go off book because the way they have it ordered is, I think it's stupid. So instead of calculating the correlation coefficient first, let's calculate the equation first and then calculate the correlation coefficient, because the equation is the model. It's what we're going to use to make predictions. And the correlation coefficient is the calculation that tells us how good the model is compared to the actual data. And so instead of doing it the way the book has it, we're going to do the equation first. And I'm going to show you how to do it with technology. If you want to do it by hand, be my guest. Take a look at the book. They actually do a very good job of explaining it. But I am not going to require you to do these very tedious calculations, and you should use technology. So you could either use your calculator, or what I would recommend is using the spreadsheet. But either one will give you a very good way of doing it. So before we venture on to that, I do want to point out the variables differences between the statistical numbers and the algebra numbers. So in algebra, we use the equation y equals mx plus b for a linear equation. And in statistics, they still use the y, but they put a little hat on the top, right? Because it deals with data. So the m is actually a b. So it would look like this: bx plus a. I know it drives me crazy, but oops, I had it backwards. Let me try again. I always have to relook at this. So what would be? It's typically written like this: a plus bx. So I had it right, but I just had it oriented wrong. Where a is the y-intercept and b is actually the slope. So it's kind of annoying, but you see, when you use technology, they're going to give you these values, and you need to know how to correspond those to the equations. And your calculator gives you a and b, and a is the y-intercept and b is the slope. Okay, well, let's take a look at how technology will help us with this. So again, we're going to use the housing data that we had in the first, where we introduced the scatter plot. And here's the scatter plot. And so again, you can see we have a strong positive linear slope hill, which makes sense with regards to, as the bigger the house, the more it should sell for, right? And so to do this calculation, you do something called the least square regression analysis. And again, you can walk through this by hand. It's very tedious, or you could use technology, and that's what I'm going to show you. So the idea here is that if you use the calculator, you have the data put in already, which is great. So you do that via the scatter plot. And so, and again, what it says here is these lines are usually computed with technology rather than by hand. And so I can put that in bold to make sure everybody sees that. And so you go down to this diagnostic on, and then enter twice. And so definitely take a look at the book and turn on the mode menu. And then when you do that, you enter the values like we did before, and then you press stats and calc. And then number 8 is this linear regression. And you can see it even has the a plus bx. So once you enter that all into your calculator, out comes the a and the b value. And you can see the a value is 160 and some change, And the B value, the slope is just about 0.1, right? 0.0992. So again, a positive slope. So what this implies is that if you had 0 square footage, you would still sell it for $160,000, right? So what would that might be? That might be what the land might be worth, right? The land that it would be on. And we have to be very careful sometimes, because sometimes depending on what values that we plug in for X, if you move it too far away from where the data actually was, it might not give you a good prediction. And we're going to talk about that quite a bit later when we talk about how to do predictions. So that's how you do it using your calculator. The book has some more detail when you take a look at that. So I highly recommend reading the book if you decide to use your calculator for these calculations. Okay, so how do you do it using the spreadsheet? Here's where it's quite nice. There are a couple different ways. I'll show you both ways. I'm going to show you the way I typically do it, because I usually don't worry about all the other crazy stat stuff. I want the equation, and we'll talk about the correlation coefficient in the next recorded lecture. So the idea here is that you do the scatter plot, and I think it's important to do that because it's nice to have a visual. And then what you do in Excel is once you have the scatter plot, just click on any data point and all of them will highlight. And then what I do is that you want to do something called add trend line. And so if you right click one of the data points, the second from the bottom says add trend line. And this wonderful menu of different options comes up. What we're going to do in the trend line options is only the linear. I love all these other ones, and as a mathematician, we use these quite a bit, but in stats, we just focus on linear. So we'll click on linear there. So if you go down to the bottom, there are things you can click. There are the last two you should always have check marks in. And the first one says display equation on chart. And the second one is the R squared value. And we'll talk about that in the next lecture. But click on both of those and up comes our equation. And if you can see that, see if I can make it a little bit bigger. Yeah, here we go. You can see that it gives you the equation where the B value here is 0.0992. And our A value, or the y-intercept's 160.19. So exactly what we got in the calculator as well. So both of them are good tools. You know my love of Excel since you've been with me here in class. And so, as I like to say, pick your poison. Get good at one of them, because we're going to be using it throughout this whole chapter. And so that ends the recorded lecture for the linear regression analysis for generating the equation.